Now, parabolas have a lot of other elements when you are finding the geometric definition of the parabola. They have the vertex, they have the focus, and they have the directrix. If you're given the vertex and the directrix, I would always, I suggest that you sketch both elements. So the vertex is at -2, comma, -1. So this is the vertex. And if the directrix is at x equals -8, that's going to be a vertical line over -8. So it's going to cross the x-axis at -8. Basically, this tells you what axis you're going to be crossing. And if this is the vertex is going to always opposite to the directrix. So we'll never cross the directrix in any way. So that means that the parabola will open to the right. Because otherwise, if we were to open up, if you try to open this parabola up, eventually you would be crossing the directrix, and that's not the idea. And if you try to open this parabola downwards, going downwards, it would once again collide with the directrix. So once again, not the idea. And if you try to open to the left, this parabola, you will necessarily have to go through the directrix. So that means that our only option is this parabola opening to the right. And if this, let me highlight it. If this is our vertex and the vertex is always at h comma k, that means that h is equal to -2 and k is equal to -1. Now that we know that this is horizontal and it opens to the right, it means that the value of p needs to be positive. So we're gonna use this equation. Y minus k squared is equal to 4 times p times x minus h. Now that we know what h and k are, we have to substitute those on our equation. Just be careful, k is -1, so we're gonna have y plus 1 squared, then 4p times x minus h is -2, so x plus 2. Now that we have those elements, we need to find p. And p is basically the distance from the vertex to the directrix or the focus. So this right here is gonna be the distance p. And in order to find p, well, if we're going from -2 to -8, that is a distance of 6 units. And if you wanted to find the focus, you would have to go the same distance. So this is 1, 2, 3, 4, 5, and 6 this way. So the focus is going to be at 1, 2, 3, 4, 5, and 6 units this way. And because it opens to the right, as I said, p has to be greater than 0 or positive. So if p is 6 units and the parabola is opening to the right, we're going to use +6. So we're going to do y plus 1 squared is equal to 4 times 6 times x plus 2. So finally, we have y plus 1 squared is equal to 4 times 6, 24, and x plus 2. And I'm going to throw a new piece of information, something called as the latus rectum, which helps you find the opening of the parabola at the focus. So Alex won't ask you for that yet, but if you use the latus rectum, that is the absolute value of 4 times p. So that is going to be 4 times 6. The absolute value of that is going to be 24. But that is an opening of 24 at the focus. So that means that we're gonna do 12 units each way. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that first sketch that we did was not accurate. The parabola goes more like this. No, not my best sketch, but that is a rough sketch of the parabola. So once again, the vertex is in between the focus and the directrix, and the distance between the vertex and the directrix is P, as well as the distance from the vertex to the focus. And in this case, we can get rid of the first or initial sketch to get our final graph.